Questions 21 to 25 on the 2006 Grade 10 AMC 10B. For a peculiar pair of dice, the probabilities of rolling 1, 2, 3, 4, 5, and 6 on each die are in the ratio 1, 2, 3, 4, 5, 6. What is the probability of rolling a total of 7 on the 2 dice? These are the ratios of the probabilities. So instead of just 1, 2, and 3, I'm going to write them as x's. X, 2x, 3x, and so on. Now the total here, if you add all these up, x plus 2x, 3x, and so on, it'll be 21x. Okay? So that's going to help me because that is the total. And I've got to divide each of these probabilities, each of these numbers by 21 to get a probability. So here we go. We want a sum of 7, right? So how do we get a sum of 7 on 2 dice? We can have either 1 and 6, 1 on the first dice and 6 on the second dice. We can have either 2 and 5, 3 and 4, 4 and 3, 5 and 2, and finally 6 and 1. Okay, so we'll figure out the probability for each of these. What's the probability of getting a 1? Well, it's 1 out of 21. Okay, remember earlier I said we have to take the numbers and divide them by the total to get the probability. What's the probability of getting a 6? It's 6x divided by 21x. So that's 6 over 21. All right, so that is the first guy. And the second one, 2, what's the probability? It's 2 over 21. To get a 5, it's 5 over 21. And in a very similar way, 3 over 21 to get a probability, the probability of getting a 3, and 4 over 21 to get a 4. 4 over 21 times 3 over 21, 5 over 21 times 2 over 21, and finally 6 over 21 times 1 over 21. And to get the probability of this question, we have to add all these. Okay? So that would be 6 over 21 squared plus 10 over 21 squared plus 12 plus 12 plus 10 plus 6. And the denominator for all of those is 21 squared. So when you add up the numerator, you get 56 all over 21 squared. And let's see here, 56, 21 squared is really just 3 times 7 times 3 times 7, like that. And 56 is really just 7 times 8. So if you write it like that, you can quickly cancel out one of the 7's. And you're just left with 8 over 9 times 7, which is 63. And there you go. Number 21, the answer is C. Elmo makes N sandwiches for a fundraiser. For each sandwich, he uses B globs of peanut butter at 4 cents per glob and J blobs of jam at 5 cents per blob. The cost of the peanut butter and jam to make all the sandwiches is $2.53. Assume that B, J, and N are positive integers with N greater than 1. What is the cost of the jam Elmo uses to make the sandwiches? So we've got N sandwiches, and we've got B, what are they calling it? Globs of peanut butter, PB, and it's 4 cents per glob. And then the jam is blob, and that represents jam, and that's 5 cents per blob. Okay? Now, we are told that the total cost is $2.53. I'm going to convert that to just cents, 253 cents, like that. Now, for each blob, I guess, of peanut butter, we've got to multiply that by 4 cents. So 4 times B. And add to that 5 times J, where J and B represent the number of globs and blobs of this stuff. Now, of course, this is a total to make all the sandwiches, so we've got to multiply this by N, which represents the number of sandwiches. Okay? And I think that's it. That's all they give us. They don't give us anything else. So we've got to do this by inspection. And the only thing that will help us is knowing that both N, B, and J are integers. Okay. Well, let's start dividing 253 by numbers and see what we get. If we do that, when I get to N equals 11, this works out. It becomes 253 divided by 11 is 23. All right? So our formula essentially reduces to this right there. Now this will be true if you have integer values for B and J as follows. If B equals 2 and J equals 3. You'll get 8 plus 15, and that is indeed equal to 23. So there you go, just by inspection. That's really the only way, since we only were given one equation. Now we want the total cost of the jam. Total cost of the jam looks like, let's see here, 5 cents. And then how many blobs do we have? 3, correct? 5 cents, and then we had J equal to 3. And we have to multiply that by the number of sandwiches, which is 11. And we figured out was 11. So 15 times 11 is 165 cents. And in dollars, that would be $1.65. So number 22, the answer is D. A triangle is partitioned into 3 triangles and a quadrilateral by drawing 2 lines from vertices to their opposite sides. The areas of the 3 triangles are 3, 7, and 7 as shown. What is the area of the shaded quadrilateral? Okay. First, let's draw a line from this vertice all the way down to that point right there, and divide that shaded region into 2 parts, and I'll call those 2 parts A and B, like that. And then I don't want to make this too complicated, so I'll just label this side X and this side Y, and this side I will label it anything you want, really. M is fine. And then this side I'll label it N. Okay? And throughout this question there's one theme, and that is if you have triangles that have the same altitude or same height, then the ratio of their areas is the same as the ratio of their bases. So if the 2 triangles have the same height, then the ratio of their areas is the same as the ratio of their bases, and we will use that theme or rule throughout this question. So here we go. First, let's concentrate on this side right there, the X and Y side. X over Y is the same as A over 3. Okay, entirely based on this rule right here. So that relationship is true if you're only looking at this part of the triangle. Okay? Now let's look at a bigger part of the triangle, which would be the entire triangle like this. And if you do that, then our ratio of X over Y would be A plus B plus 7 over 3 plus 7. Okay? So since X over Y equals this and X over Y equals that, we can set those equal to each other. So A over 3 is equal to A plus B plus 7 over 3 plus 7, like that. And this will give me a simplification of, let's see, cross multiply 10A is equal to 3A plus 3B plus 21. And that looks like 7A is equal to 3B plus 21. All right, so that's about as far as we can go there. Now let's look at the other side. This side right here with the m's and the n's. First, let's just look at this part of the triangle. And if you do that, you get m over n is equal to b over 7. Okay? Now let's look at it from the perspective of the entire triangle, like that. If you do that, you get m over n is equal to a plus b plus 3 all over 7 plus 7. All right? So now, just as before, we set these equal to each other, and we can then figure out another equation. So cross multiplying, we get 14b is equal to 7a plus 7b plus 21. And this looks like 7b is equal to 7a plus 21, like that. And there you go. We've got our two equations. We've got this equation and we've got that equation. From this one, I can probably isolate for a 7a by just putting the 21 on the other side, like that. And therefore, since 7a equals this and 7a equals that, we can set those two equal to each other. So 3b plus 21 is equal to 7b minus 21, and therefore 4b is equal to 42, and b is equal to 42 divided by 4, which is 10.5. And substituting back into any one of these to get the value of a, you will get a is equal to 7.5, and therefore a plus b, which is the area of our shaded region, will be 18. And a plus b was indeed the area of our shaded region, and 18 was the answer to number 23, which is choice D. Circles with centers at O and P have radii 2 and 4 respectively, and are externally tangent. Points A and B are on the circle with center O, and points C and D are on the circle with center P, are such that AD and BC are common external tangents to the circles. What is the area of the concave hexagon Aobcpd? The first thing in this question is to draw two lines that are parallel to AD. Right there, that's the first one, and the other one parallel to BC, like that. Drawn in such a way so that these are right angles, like this. All right, so let's blow this up a little bit because I think we're going to need to do that. Now let's start labeling as much as we can. This is 2, that's already labeled, therefore this is going to be 2, the distance from there to there. Now this whole distance was 4, so therefore the distance from here to here will be 2. Okay, and then let's see here in a very similar way, this is 2, this is 2 therefore, and therefore that is also 2. Not exactly drawn to scale, but that's okay. And then anything else? We need to figure out this distance right here, from there to there. If we can figure out that distance, this question will be solved. So whatever that distance is, I'll just call it x. And we can use Pythagoras. So x squared plus 2 squared is equal to 6 squared. So that means x squared is equal to 36 minus 4. So x is equal to the square root of 32. Now, the area of this whole thing, is first and foremost this rectangle, and this rectangle. There's two of them, right? And they're identical. So two rectangles, like that. And then add to that this triangle, which is identical to that triangle. So two of those identical triangles. So two triangles. Okay, so here we go. Each of those rectangles, length times width. Well, the width is 2 right here, and the length is x, which we just figured out was root 32. So root 32, like that. And then 2 times the triangles, 1/2 base times height is the formula. And base, well, it doesn't really matter. We can use this as the base and that as the height. So the base is x, which is root 32, and the height is 2. So this becomes, let's see here, 4 root 32 plus 2 root 32. So that looks like it's 6 root 32. And then 32 is 16 times 2. So 16 times 2, like that, under the square root sign. And then you can kick out the 16. And when you do, it becomes 4, like that, times root 2. So this is 24 root 2. And there you go. So the answer is right there in front of us. It's B. And that is for question number 24. Mr. Jones has 8 children of different ages. On a family trip, his oldest child, who is 9, spots a license plate with a 4-digit number in which each of the 2 digits appears 2 times. "Look, Daddy," she exclaims, "that number is evenly divisible by the age of each of us kids." "That's right," replies Mr. Jones, "and the last 2 digits just happen to be my age. Which of the following is not the age of one of Mr. Jones' children?" So we've got a license plate number that has 4 digits, and 2 digits are repeated twice. So basically something like this: AB, AB, or AA, BB, something like that. Okay? And this number is divisible by all the ages. And the last 2 digits, whatever they are the age of the father. All right, so I'm just going to look at the answer choices and work with that. If this number, whatever it is divisible by all the ages, then it's got to be divisible by all of these except 1, correct? So which one is it not divisible by? I'm not sure, but these all are even numbers, and we've got 2 odd numbers. So that makes me think that the number that it's not divisible by is one of those 2. Okay, well, I don't know. So let's say that 5 is the one that it's not divisible by. Okay? So if that is indeed the answer, that means it's divisible by all of these guys: 4, 6, 7, and 8. So what we have to first do is figure out the lowest common multiple of these numbers and work with that. Okay, well, 4 is 2 times 2, 6 is 2 times 3, 7 is a prime number, and 8 is 2 times 2 times 2. So the lowest common multiple of 4, 6, 7, and 8 will be, you have to use the 2 3 times. You have to always use the maximum number of times it appears. So it'll be 2 times 2 times 2. The 3 appears in a maximum of 1 time, and the 7 appears maximum 1 time. So this is my lowest common multiple: 2 times 2 times 2 times 3 times 7, which is 168. Now my number has to be some multiple of 168. Okay? And when I do that, the last 2 digits will represent the age of the father. And also, the number has to only have 2 digits in it, appearing in some order. It could be like this, or it could be BA, BA, something like that. Okay? Or the only other way would be like BBAA. Okay, so we have to, in a very painstaking way, figure out this number here. But there's actually a clue in the question stem that you might have actually missed. His oldest child is 9 years old. So 9 also is going to divide our number. So they mentioned that for a reason. It's not just something they've said in passing. So instead of just 4, 6, 7, and 8, I'm going to include the 9 in there. And I'll find the LCM of that. And that will help me out a little bit better because it will be a larger number. Well, 9 is 3 times 3. And therefore the LCM this time, 2 appears maximum 3 times, so that's going to be the same kind of story. 3 appears a maximum of twice, so I'm going to use the 3 twice. And I think the 7 is the only other one. So now this is my LCM. And that is 504. So I think that helps. Makes us have to do a little bit less work. So now I've got to find a multiple of 504. Okay? Shouldn't be that bad. Let's see here. 504. I'll write them on the side here. 1008. 1512. I'll stop when I reach something that looks something like this or something like this. So far nothing. 2520, 3024, 3528, 4032, 4536, 5040, 5544. There you go, 5544. That is in this form right here. Now let's see if it meets our criteria. First criteria is that it has to be divisible by all the ages. And we actually don't know all the ages, but all the ages that we do know, 9, 4, 6, 7, and 8, it divides those. We know that for a fact because we've basically got the LCM. Okay? So that's the first criteria. Second criteria is the number has to have only 2 digits, and each of those 2 digits has to be repeated twice. So the digit criteria is definitely met because the number is 5544. And any other criteria? Yeah, the last 2 digits have to be the age of the father, and I mean 44 is definitely a realistic number for the age of a father. And there you go. That's the answer. So after all that work, which of the following is the age that is not one of Mr. Jones's children? Well, it's 5. So I got a little lucky there, and I chose the right one. So number 25, the answer is B.